Hey everyone, today let's talk about something we've all faced, getting totally stuck on a math problem. But what if the secret isn't about finding that one right way to solve it? What if it's about having a whole toolbox of different strategies you can pull from? Let's dive in.
We've all been there, right? You're just staring at a problem and you're convinced there's some secret formula you're supposed to know, and if you can't remember it, well, you're just stuck. It is such a frustrating feeling.
Well, we're going to flip that perspective on its head today. We're not just going to solve a couple of problems. We are going to build a mental toolbox. The whole idea is to get you set up with different ways of thinking, so you can pick the best tool for whatever job is in front of you.
Okay, first up, let's crack open our first case file, this schedule puzzle. This one's all about spotting patterns and figuring out cycles. Okay, so here are the facts. We've got Brian, who works 5 days on, 2 days off. Then there's Linda, who works 3 days on, 1 day off. We know for a fact that April 1st was a day off for both of them, and they both started their work week on April 2nd. So, the mission, should you choose to accept it, is to find every other day in April that they both get off work together.
Now, here's the cool part about this problem. There is not just one way to figure it out. We're going to walk through two totally different but equally correct strategies. This is where that whole toolbox idea really starts to come to life.
Our first tool is perfect for all you visual thinkers out there. Instead of just trying to crunch a bunch of numbers in our heads, let's actually draw it out. Let's map out the entire month and just see what the patterns look like. We're going to build a calendar.
So here's how that first approach looks. We literally map it all out. We know April 1st is the day off for both. Simple enough. Then, starting on the 2nd, we just plot out Brian's schedule. 5 B's for his workdays, then 2 blank spots for his days off. Then, we do the exact same thing for Linda with an L for her 3 on, 1 off schedule. As you fill out the calendar, all you have to do is look for the days that have neither a B nor an L. And bingo, there they are, April 21st and April 29th. Problem solved.
But hey, what if you're not a visual person? What if drawing up a whole calendar just feels like a lot of work? No problem. Let's pull out a different tool, the good old simple direct list. This is for the folks who just like to get straight to the point. Okay, so for this to work, you have to get Brian's cycle down. He works 5 days, has 2 off, so that's a 7-day loop. We know he was off on April 1st, so his next days off are going to be the 7th and the 8th, and then after that, the 14th and 15th. You see the pattern? We just list them all out for the month. Now we do the same exact thing for Linda. Her cycle is every 4 days, so after April 1st, her days off are the 5th, then the 9th, the 13th, and so on. Now for the easy part. You just put the two lists side by side and look for the numbers that match. And what do you see? The 21st and the 29th. Same answer, totally different method. And this just shows you the whole point perfectly. The visual map is fantastic for seeing the big picture all at once. The list is super fast and direct. Neither one is better than the other. They're just different tools. The best one is whichever one clicks for you. All right, ready for round 2? Let's move on to our second case file. This one is a classic work problem, and it's going to require a completely different tool from our toolbox. So here's the setup. We have 2 machines. One is a little slower, and it takes 40 hours to do a job. The other one is bigger and faster, and it only takes 30 hours. So the question is, if they work together, how long will the job take? Now, the trap everyone falls into is just averaging the 2 times. But trust me, that doesn't work. We need a new tool for this. And that new tool is all about reframing the question. This is a game changer. Instead of thinking about the total time it takes to do the whole job, the trick is to think about how much of the job they get done in just 1 hour. We got to start thinking in terms of rates. This makes the whole thing way less scary because it breaks it down into 3 simple steps. First, you figure out the fraction of the job each machine does in 1 hour. Second, you add those 2 fractions together. And third, you use that combined rate to figure out the total time. See? It makes a tricky problem feel way more manageable. So let's actually do it. If the smaller machine takes 40 hours for the whole job, that means in 1 hour, it does 1/40th of the job. Makes sense, right? And the larger machine does 1/30th of the job per hour. To add those together, we need a common denominator, which in this case is 120. So that's 3 120 plus 4 120, which means together they knock out 7 120ths of the job every single hour. Okay, so if they complete 7 1/120ths of the job each hour, how long till the entire thing is done? Well, to figure that out, you just flip the fraction.
you take the reciprocal. So 120 divided by 7, and that gives us our final answer, 17 1/7 hours.
And it's always a good idea to do a quick gut check to make sure it makes sense. So in that 17-ish hours, the slower machine does about 3/7 of the work. The faster one does the other 4/7. You add them up, 3/7 plus 4/7 is 7/7, which is one whole job. Yep, the math works out perfectly.
So we just cracked two very different cases. What's the big takeaway here? What did we actually put in our problem-solving toolbox today? We've added 3 really powerful tools. First, the power of visualizing a problem. Sometimes drawing a picture can make everything click. Second, the direct approach of just listing out your data to find where things connect. And third, maybe the most important one, is the skill of reframing the question, like we did when we switched from total time to hourly rates.
So the next time you feel stuck, and it doesn't have to be a math problem, it could be a scheduling issue or a project at work, don't just hunt for that one right answer. Think about your toolbox. Could you draw it out? Could you make a list? Could you maybe just look at the whole problem from a different angle? Sometimes a fresh approach is all you really need.